So, ladies and gentlemen, today we're going to work a little bit more with complex numbers. So we're going to talk about how you would add two complex numbers. So you see here, we have, with a complex number, we have a real part and an imaginary part. So what we're going to do when you add them is you simply add the real part then add the complex part. So to model for number one, we have the real parts, 2 plus 3, and that's going to give us 5. And then in looking here, we have minus 4 plus 5, so we view this as negative 4. And negative 4i plus 5i is going to give us 1i. So I can write plus 1i or just plus I. So in checking your answers, if you add the real and complex parts for each of B, C, and D, that's what you should get. So again, to just sum up addition of complex numbers, you add the real number parts and you add the complex number parts. So part 2 for subtraction, what you're going to do is subtract the real part then subtract the complex part. So if I'm looking here, we have 2, and I have to minus 3. So if I do 2 minus 3 for the real part, that's going to give me negative 1. And then I have negative 4, but negative 4i, and I'm subtracting 5i. So negative 4i minus 5i gives me minus 9i. So what I want for you to do is complete B, C, and D. So ladies and gentlemen, if you check your answers for B, C, and D, here you go. So as we look at multiplication, what we're going to do is multiply binomials using the distributive property. And we're also going to remember that if we square I squared equals negative 1. So in looking at our first one, if I have 2 minus 4i times 3 plus 5i, I'm going to multiply this out using distribution. So I would multiply 2 times 3, which is 6. And then I would also multiply 2 times the 5i. And 2 times 5 is 10. And then we keep the I, so 10i. And then we move on to the inside term. And we go negative 4 times 3. And negative 4 times 3 would be minus 12i. And then we go negative 4i times 5i. So negative 4 times 5 would be minus 20. And then I times I is going to give me I squared. Now we're going to simplify a little bit. So we have 6, and then I combine 10i minus 12i, so minus 2i. But now here, this I squared, we have to recall I squared is negative 1. So we have minus 20, but I'm timesing that by negative 1. So in looking at the overall effect, this is going to be plus 20. So this right here turns into 6 minus 2i plus 20. And then finally, we would combine our 6 and the 20 to make this 26 minus 2i. Now, some of you, ladies and gentlemen, use the area model, and that is perfectly okay. So I'm going to show how you would do your work using the area model. So here, for our length, we have 2 and negative 4i. And then for our width, we have 3 and 5i. And then we multiply each. 2 times 3 is 6. 2 times 5i is 10i. 3 times 4i is minus 12i. And then 5 times 4 is negative 20. And then what I'm going to do here, I know that when I have I times I, it's going to make I squared. But I'm just going to put that as timesing by negative 1 to save myself some work. So if I look at the overall effect, that's going to give me 6. And then I'm going to simplify inside. Negative 12i plus 10i is going to give me minus 2i. And then here, if I have negative 20 times negative 1, that's going to give me plus 20. So to combine my like terms then and put my real part first, 6 plus 20 is going to give me 26, and then minus 2i. So to compare your answers for part B, C, and D, here's what I got. And now we're going to move on to the backside of our notes. And what I want for you to do again is multiply negative 3 plus 2i times 4 minus 6i without a calculator. So go ahead and do that, and I'll pause. So ladies and gentlemen, if you multiply that out, when you simplify, you get 26i. So now I'm looking at example 2, write a quadratic equation in general form that has the given zeros. So if x equals 2 and it's a double root, that means that x equals 2 is repeated twice. So in working backwards to figure this out and put it in factored form, we can subtract 2 from both sides of both equations and say we have x minus 2 equals 0 repeated twice. So then to move this into factored form, we could say that y is equal to x minus 2 times x minus 2. But we're not done. It says to put that in general form, which is another word for standard form. So we're going to have to distribute and simplify. So again, distributing x times x gives me x squared. X times negative 2 gives me minus 2x. Again, negative 2 times x would be minus 2 more x. And then negative 2 times negative 2 would be plus 4. Simplifying, negative 2 plus negative 2 would be minus 4. So it would be y is equal to x squared minus 4x plus 4. Now, the second part of this, where we have roots, and it's going to be a double root here that is complex. This was one that I pondered and solved for a very long time. So I did not know how to get this right away. It took me a very long time to think about, well, how can I go from a complex number to real? And then I remembered something. If I take I and square it, I can make negative 1. And I can use that fact. If I could get I by itself and then square it, I can get rid of the I. So what I did then was get rid of the 4 and divided both sides by 4. So what I'm going to do here is call that 1/4 x. And then that equals I. So that took me quite a long time to figure out a strategy for doing this. And then if I squared both sides, I could get rid of the I. So remember, when we square a product, this would equal 1/4 squared times x squared, and then equals I squared again is negative 1. So 1/4 squared means 1/4 times 1/4, and that would be 1 over, and then in the denominator, 4 times 4 is 16. So we would have 1/4 x squared equals negative 1. And then we need to add the 1 to both sides to move it over. So we would have y equals 1/16 x squared plus 1 equals 0. To write this in function form, we're going to replace 0 with y and switch sides. So instead of 0 here, I'm going to put y, and then moving everything to the other side of the equation, I'm going to have y equals 1/16 x squared plus 1.